Hi Neet Aspirants, welcome to Vari Medical Academy. Vari Medical Academy சார்பாக அனைத்து விதமான டாபிக் சார்ந்த ஒவ்வொரு வீடியோவும் இனி வரும் நாட்களில் உங்களுக்கு வரும். உங்களுக்கு இதை சார்ந்த சந்தேகங்கள், கேள்விகள் எதுவாக இருந்தாலும் கமெண்ட்ஸில் பாஸ் பண்ணுங்கள். எங்கள் எக்ஸ்பர்ட் ஃபேக்கல்ட்டி மெம்பர்ஸ் போடுற வீடியோஸ் பிடிச்சிருந்ததுன்னா ஷேர் பண்ணிக்கோங்க. அந்த வீடியோ ரெகுலராக உங்களுக்கு வரணும்னா சேனலை சப்ஸ்கிரைப் பண்ணிக்கோங்க. தேங்க்யூ. Wish you all the best.
Yes, good afternoon students. Already we discussed states of matter. States of matter in the first class. States of matter means the matter can be exist in solid, liquid, gas, and after more intermolecular forces present in solid, less intermolecular forces are present in gas. I discussed van der Waals forces of attraction in first video, and second video we have to discuss and gaseous measuring parameters. The gas, how to measure the parameter, important parameter. Gas measuring properties, gas measuring, to measure the gas measure properties. What are the gas measuring parameters? Now first one is I am taking first one is the weight. First one is weight. Weight or mass. We can take mass. Another one is a temperature. Temperature, that is T. And next one is pressure. Pressure, that is P. Next one is volume. Volume, V. Next one, density. Density, that is D. What are the gas measuring properties? The parameters. One is weight or mass, and next one is the temperature. Next one, pressure, and volume, and density. What are the students? First one is weight, temperature, pressure, volume, density. These are the, actually the major is the gas measuring means the temperature and pressure, and weight of the gas, temperature, pressure, volume, density also important. We can discuss. First one is the weight. Weight or mass. Weight or mass. Mass means you take some empty cylinder. I am taking empty cylinder. The empty cylinder weight is W1. The empty cylinder weight is W1. Now after I filled this gas, the empty cylinder, the fellows are came and they filled the gas. Now here is gas is filled another cylinder with gas, that is the weight of gas is W2. The filled gas, empty cylinder after filling gas, that is W2. Weight of this cylinder is W2. This is W1. Now weight of the gas or mass of the gas, that is equal to W2 minus W1 grams. W2 minus W1 grams. This one minus this one, you get weight of the gas. Next, we can take number of moles of gas. Number of moles of gas. Number of moles of gas is equal to weight of the gas or mass of the gas, weight of the gas by molecular weight of the gas. Molecular weight of the gas or molecular mass of the gas. How to remember? Number of moles of gas is equal to weight of the gas by molecular weight of the gas. Otherwise we can write mass of the gas by molecular mass of the gas. This is the first parameter to measure the gas. The gaseous molecules are far away from each other. More entropy is present. Now we are discussing about the gaseous state. The gaseous state we can measure mass, temperature, pressure, volume, density. The first one is the mass. Now empty cylinder I am taking, that is the weight is W1. After filled, the gas is filled with gas to empty cylinder, that is the weight is W2. Now weight of the gas is equal to W2 minus W1 grams. Now another one is the number of moles of gas is equal to weight of the gas by molecular weight of the gas. Next coming to the another parameter, temperature. Next to parameter is temperature. What is temperature? Temperature can be measured in centigrade and Fahrenheit and Kelvin. The temperature can be measured in Kelvin, centigrade and Fahrenheit. But in gaseous state we can use Kelvin, a degree centigrade. Now the kinetic, what is temperature, students? Temperature, it can be denoted as symbol T. Temperature, that is kinetic energy of the gas. Kinetic energy of the gas. Kinetic energy of the gas, that is temperature. Now temperature can be measured in Kelvin. Temperature can be measured in Kelvin and degree centigrade, even Fahrenheit also, but we cannot use in gaseous state, maximum Kelvin and degree centigrade. Now what is the relation between degree centigrade temperature and Kelvin temperature? Now Kelvin temperature, K is equal to 0 degree centigrade plus 273. Kelvin is equal to degree centigrade plus 273. This is the relation between Kelvin temperature, degree centigrade temperature. At 0 degree centigrade means that is equal to 273 Kelvin. 0 degree centigrade means 273 Kelvin. What is the relation between temperature in degree centigrade and Kelvin temperature? Kelvin is equal to degree centigrade plus 273. Remember this one. At absolute zero, that zero temperature, at absolute is zero, and kinetic energy of the gas, is zero. Kinetic energy of the gas is zero. Next to volume of the gas is, volume of gas also zero. Pressure of the gas also zero. At absolute zero. At zero temperature, the kinetic energy of the gas is zero, volume of gas is zero, pressure of the gas is zero. This is the another parameter to measure the gas. One is temperature, kinetic energy of the gas. Simple, the temperature can be measured Kelvin, degree centigrade. Now Kelvin is equal to 0 degree centigrade plus 273. This is the temperature. Next one is the volume. Next one is the volume and pressure and density. Next write down temperature after volume. The volume symbol is V. Volume can measured in liter and decimeter cube. Volume can be measured in liter and decimeter cube. Now, what is the volume of the gas? For example, in this room, any gas is spreaded, any gas is released, it can be spreaded all over the room. That is, volume of the gas is equal to volume of the room. If the volume of gas is equal to the gas molecule occupied the vessel, means volume of gas is equal to volume of container, volume of container, because this can be spreaded all over the container. That's why volume of gas is equal to volume of container. Now, volume can be measured in liter and decimeter cube. Now, 1 meter cube is equal to 1000 liters. That is equal to 1000 decimeter cube. That is equal to 10 की power 6 centimeter cube. Next, 10 की power 6 milliliter. This is the volume can be measured in volume of the gas is equal to volume of the container. Because if in this room any gas I released, for example any perfume released, that perfume can be spreaded all over the room. Now, what is the volume of the gas? Volume of the room. That's why the gas occupied volume is volume of gas is equal to volume of container. Because if you take any container, this one is the container I am taking. Now we can release the any gas, any perfume are released. Now the gas particles are all over the vessel. This is the volume of gas is equal to volume of container. 1 meter cube is equal to 1000 liters. Now 1000 decimeter cube, 10 की power 6 centimeter cube, 10 की power 6 milliliter. Next, another important parameter gas can be measured. Next one is the pressure. Pressure. It can be denoted as P. It can be denoted as P. Now I am taking on vessel. In this vessel, the molecules are colliding with each other. Molecules are colliding with each other. Again, collisions with each other. One molecule to another molecule. Again, collisions with the walls of the container. Again, collisions with walls of the container. What is pressure? Pressure means force acting on unit area. What is pressure? Force acting on unit area. That is called pressure. Now pressure, force can be measured in Newton by area meter square, that is equal to Pascal. That is equal to Pascal. Pressure, you know, pressure actually in a vessel, the molecules are present. The gas which contain number of particles, more number of particles, that is called molecules. These molecules are collide with each other. Again, collisions with walls of the container. Now here colliding, here is what is pressure? Pressure means force acting on unit area, that is called pressure. Now force can be measured in Newton's units. Area meter square, Newton by meter square is equal to Pascal. Now we can write pressure measured. Pressure can be measured in ATM, atmospheric pressure. Next one, bars. Next one is the torr. Next one, these are the units ATM, bars and torr. The units of pressure. Pressure can be measured in ATM, bars and torr. Next one, Pascal. Now, what is the pressure? the pressure means force per unit area. Now it can be measured in atm, bars, torr and pascal. We can measure the pressure. Now 1 atm, here write down students, 1 atm, 1 atmospheric pressure is equal to, we can write 760 mm of Hg, 760 mm of Hg, or we can take 76 centimeter of Hg, or 760 torr, 760 torr. These are the, we can 1 atm is equal to, we can write this the points, 1 atm is equal to 760 mm of Hg, 76 centimeter of Hg, 760 torr. This is the pressure, can be pressure measuring, to measure the gas pressure is the very important. And next one is the last one, density. What are we discussed, students? On the first one is the weight of the gas, next one is temperature, next pressure and volume, and last one is density. Density. What is density? The weight of 1 liter of water, the weight of 1 liter of water, that is called density. Density, you know, weight of 1 liter of water. If you take density symbol D, D is equal to, density is equal to mass by volume. We can write density is equal to weight by volume. Now weight is equal to density into volume. Remember this one. Density is equal to mass by volume. If density increases, volume decreases. Remember. Next, absolute density D is equal to Pm by RT. Density is equal to Pm by RT. What is P here? Pressure. What is M? Molecular mass. What is R? R means universal gas constant. Universal gas constant. That is equal to universal gas constant means R. Now T is equal to temperature in Kelvin. Temperature in Kelvin. Now M is equal to molar mass. Molar mass or molecular weight. Now P is equal to pressure. Pressure, 1 atmospheric pressure. Now density, remember the weight of 1 liter of water is called density. Here density is equal to mass by volume. When density increases, volume decreases. Density is equal to weight by volume. Now weight is equal to density into volume. Now absolute density is equal to Pm by RT. Now R is equal to universal gas constant. What is the universal gas constant? 0.0821 atm liter mole and Kelvin. Atm liter mole and atm liter per mole and Kelvin. This is the one of the unit of R. And next to pressure, we can take 1 atmospheric pressure. M means molar mass, T means temperature. What are the parameters we can measure the parameters of the gas? Gas can be measured. The main parameters are, one is the mass of the gas or weight of the gas, temperature, pressure, volume, density. These are the parameters to can measure the gas. But next to gaseous laws we can explain based on this. One of the important point you have to remember, LPHT. LPHT, low pressure, high temperature. Low pressure, high temperature. Real gas behave as ideal gas. Real gas behave as ideal gas. Remember LPHT, low pressure, high temperature. What is the ideal gas? What is real gas? Ideal gas means the gas which obey all gaseous laws. The gas which obey all gaseous laws at all temperature, pressure. That is called ideal gas. And real gas means at particular temperature and pressure. What is the particular? LPHT, low pressure, high temperature. Real gas behave as ideal gas. Now what is ideal gas? The gas which obey PV is equal to nRT at all temperature, pressure. The gas which obey PV is equal to nRT, ideal gas equation at all temperature, pressure is called ideal gas. Real gas and ideal gas, and we can discuss the gaseous laws.